Hello everyone, today I am going to go through everything you need to know in AQA GCSE Further Maths. So for this video, I'm going to assume that you already know everything in higher maths, and I'm going to try to go through all the topic, therefore it should not replace your thorough revision, but should be a good summary of what you know. So let's start from our first topic, the domain and range of functions. So for domain, it is the possible inputs of a function. For example, we have basically two rules that we need to follow, which is we cannot have a negative square root because that will give me no real solution, so we do not want that. And then also we cannot divide by 0. This is not allowed. So that's the two main rules that we need to follow. So for example here, x must be greater or equal to 4, because if it is not greater or equal to 4, then this will be negative. You will get a negative square root, which is not allowed. Then, for this one, the domain of this function is x not equal to 3, because if x is equal to 3, then you get 3 over 0, which is not allowed. So x is not equal to 3 is the domain of this function. Next, for range, range is the possible outputs of a function. For example, for f of x equals sine x, we can have a look at the graph. So if we draw the graph of sine x, you'll realize that it always goes between 0, a positive 1, and then minus 1. So sine x can never output anything beyond those range. So the range of this function will be minus 1 less than or equal to f of x less than or equal to 1. So that is how we can find domains and ranges. Brilliant. Next, binomial expansion. So for binomial expansion, I'm going to show you the pattern. So for a plus b all to the power of 0, that's 1, because anything to the power of 0 is 1. And then here is just a plus b. And then for this one, you should memorize it, which is a squared plus 2ab plus b squared. And then finally, you have a cubed plus a 3a squared b plus 3ab squared plus b cubed. So for this, you can have a look at the pattern, which is the coefficient is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, which is the Pascal's triangle. So the coefficient follows the pattern of the Pascal's triangle, and you can construct a Pascal's triangle by writing ones at the side of the triangle, and then the middle numbers are always the two numbers immediately above it. So for example, this 3 is the sum of the two numbers immediately above it. This 4 is the two numbers immediately above it added together. So this is how you draw a Pascal's triangle. And the first row of the Pascal triangle is something to the power of 0. It's a binomial to the power of 0. And then you have to the power of 1, and then you have to the power of 2, and it goes on. So this is the pattern for the coefficient. And then for the pattern of the power, if we look at the final line, we can see that for a, the power goes from 3 to 1. There's a 1 here, and then a0, because that's 1. And then for b, we have b0 and then 1, 2, 3, because there's a 1 here and there's a hidden b0 here, because that's 1. So the general pattern for a binomial expansion is that the coefficients are the Pascal's triangle, and then the powers goes from, for a, it goes from the top number gradually going down, and for b, it goes from 0 gradually going up. So let's try to expand x plus 3 all to the power of 5. So when we have x plus 3 to the power of 5, we are going to be using this row of the Pascal's triangle, because we go 2, 3, 4, 5. So we will know that it starts with 1, and then we have x to the power of 5, and then 3 to the power of 0, which is 1. And then we have 5 times x to the 4, and then we have 3 to the 1, and then we add 10 x cubed, and then 3 squared, and then we have plus another 10, which is x squared, and then 3 cubed, and then we have a 5x, and then 3 to the 4, and then we finally have 1 times 3 to the 5, because we have x0, which is 1. So this is quite annoying to simplify, but it's not too horrible, because this gives me 15, And then 3 squared is 9. 9 times 10 is 90. And then here I get 27 times 10, which is 270. Here I get 3 to the 4 is 81. So 81 times 5 gives me 405. And then finally, 3 to the power of 5 is 243. So this will be the final answer of x plus 3 to the 5 all expanded. Brilliant. And next, we have the factor theorem. So a cubic, which means something with the power of 3, of the highest power with c, this can be factorized into a linear and a quadratic. And the reason this works is because we have the highest power of a linear is x to the 1, the highest power of a quadratic is x to the 2. So I times them together using my index law. I add the power, so I get x cubed. That's why this works. So the factor theorem states that if x plus a is a factor of f of x, then f of minus a equal to 0. So I'm going to show you what this means. So here I have a cubic with x minus 1 being a factor. So all I need to do is set x minus 1 equals 0 and then solve for x. And when we solve for x, what we're hoping to happen is that when we put in x equals 1, we're going to get 0. So let's have a look. F of 1 gives me 1 cubed minus 3 times 1 squared minus 13 times 1 plus 15. So this is 1 minus 3 minus 13 plus 15. Because 1 minus 3 is minus 2 minus 13 plus 15, which gives me minus 15 plus 15, which gives me 0. So because it is equal to 0, therefore I can say that x minus 1 is a factor. Brilliant. So I found a factor for that cubic. Hence, fully factorize this. So there are many ways you can do this. I'm going to show you the easiest way, and I'm going to show you the a bit longer way that you might need to know. But I've never seen that way being taught, being asked for specifically in the exam. But I'm still going to do it because it's technically in the spec. So here, the easy way to do this is that I'm going to say x minus 1 is a factor, and I'm expecting a quadratic in this bracket. So the only way to get from x to x cubed is to multiply by x squared. And then the only way to go from minus 1 to plus 15 is to multiply by minus 15. Because I'm expanding like this to get plus 15. Now let's think about what the x term will be here. So for the x term, I'll have minus 15x by doing this. But I want to get to minus 13x. So I need to plus 2x from this to get to minus 13x. Which means if I do minus 2x here, I will get plus 2x because of 2 minuses being a positive. Therefore, this will give me minus 13x, and this will be a correct factorization. Now, another way you can factorize a cubic is doing polynomial long division, which looks like this. I'm going to write down my cubic and then put it into a bus stop. And I'm going to divide it by x minus 1. So to go from x to x cubed, I need an x squared. And then if I multiply x squared by this thing, I get x cubed minus x squared. Now I'm going to take away like this. So I get x cubed minus x cubed. That disappears. And then minus 3x squared minus minus x squared is plusing x squared. It means I have negative 2x squared here. And I'm going to pull down the 13x. Now to get from x to minus 2x squared, I must minus 2x to get there. And then I'm going to do the same thing, multiplying this by this. So I get minus 2x squared and then plus 2x. And I'm going to take away this. So this disappears, the first one. And then the second one, I get minus 15x plus 15. And that I'm going to times it by minus 15 here. Because when I do this, I get exactly minus 15x plus 15. And it divides beautifully. So we get the exact same answer, as you can see. But we're not done yet, because we can still factorize the quadratic. So if we factorize the quadratic, we want to find two numbers that add to minus 2 and multiply to minus 15. And I think the two numbers will be minus 5 and plus 3. Because that is minus 5x and that's plus 3x, which gives me minus 2x, and then this gives me minus 15. And that will be the fully factorized cubic. Brilliant. Next, so quadratics exist in the form ax squared plus bx plus c. And normally we set it equal to 0. So the discriminant will be b squared minus 4ac. The reason for that is that in the quadratic formula, we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this square root, because we have plus or minus, actually determines how many solutions we have. So if b squared minus 4ac equals is greater than 0, then we have two solutions. Because the square root will be positive, therefore the plus or minus will give me two different solutions. Now if I have b squared minus 4ac being equal to 0, then I will have one solution because the square root will be 0. Therefore the plus or minus doesn't do anything, and I get negative b over 2a being my one only solution. But if I have b squared minus 4ac being less than 0, I have no real solutions because the square root will become negative, which means I will not have any real solutions because you cannot square roots are negative in the real world. So what this will look like is that if we have greater than 0, the discriminant, we're going to have two roots. So we're going to cross the x-axis twice. But if it's equal to 0, we're only going to have one. Okay, that is horrible. We're only going to have one root where it crosses the x-axis once. And if it's less than 0, it's not even going to cross the x-axis. So there will be no real solutions there. Limits. So to find the limiting value of something that approaches infinity, all we need to do is sub in a very big value. So what if n equals like 100,000? So if I just put in n equals 100,000, I get this. And if we think about this is equal to this. And this is approximately equal to 300,000 over 100,000, which means as n approaches infinity, that little 3 and 5 will no longer matter because of how big things are getting. Therefore, this will give me precisely 3, which means this will have a limiting value of 3. Next, so for triple simultaneous equations, we need to do two elimination processes. So what I suggest you to do is to do, so you see A, B, and C is to, actually I'm not going to use A, B, and C because that's the algebra, so that's confusing. 1, 2, 3. So I will recommend you to eliminate 1, 2, and then eliminate 1, 3. So I'm going to show you how to do that. So we have 3a minus b plus 2c equals negative 2. And then I'm going to double my number 2 to get 4a plus 4b minus 2c equals 26. 52, sorry, because I'm doubling everything. So here, if I add the two equations together, I can eliminate my c. So I get 7a plus 3b equals 50. And next I'm going to try to eliminate 1 and 3. So if I have, let's have a look what I can do with 1 and 3. Actually, I'm going to do 2 and 3 in this case because they cancel out a bit nicer. So if I do 2 and 3, I get 2a plus 2b minus c equals 26. 2a plus b plus c equals 9. So if I add these two equations, the c will cancel out, so I get 4a plus 3b equals 35. And then I can look at this equation and pull it down. So I get 7. I'm actually going to put this equation on top. So I get this, and then that. And we're going to take away to eliminate my b. So when we take away, I get 3a equals 15, so a equals 5. So we get our first solution of a equals 5, and then just put in any equation that has an a in it. So let's say this. So I get 20 plus 3b equals 35. I'm putting in a equals 5. So take away, I get 3b equals 15, b equals 5. And then finally, just put in 5 and 5 into an equation with a, b, and c. So here I get 15 if I put in 5 into a and then minus 5 plus 2c equals minus 2. So I get 10 plus 2c equals minus 2. 2c is equal to 8. No, equal to minus 12. Therefore, c is equal to minus 6. And we get our 3 solutions by doing elimination. Brilliant. Algebraic proofs. So the first question is, prove that the sum of 3 consecutive integers is always divisible by 3. So if I have an integer n, the consecutive integer must be n plus 1 and then n plus 2. So I have 3 consecutive integers here summing together, which if I add them up, I get 3n plus 3. So to prove that it is always divisible by 3, I must factorize out a 3 to show that it is divisible by 3. And that will be the answer. Brilliant. Next, prove that this is always a multiple of 5. So for these kind of questions, we just need to work through the algebra very carefully. So if I just expand the bracket, so I get n squared plus 20n plus 100 minus n squared minus 10n minus 25, then I can just group like terms. So this and that cancels out, and then I get 10n by doing 20n minus 10n, and then 100 minus 25 is 75, and then to prove that it is always a multiple of 5, I need to factorize out a 5, which looks like this, and I proved that the statement is true. Next, prove that the sum of the squares of 2 consecutive odd integers is always even. Now we need to dissect this a bit because it's slightly complicated. So first of all, odd integers, we can express it as 2n plus 1, because 2n is always going to be even. So if I add 1 to that, it will always be odd. So I want the square of 2 consecutive odd integers. So I'm going to square my first odd integer, and then sum, which means I'm adding them. And then I have a consecutive odd, which means it's going to be 2n plus 3. And then I square it. So again, I just need to work through the algebra very carefully to get 4n squared plus 4n plus 1 plus 4n squared plus 12n plus 9, I think. And then if we group like terms, we get 8n squared plus 16n and then plus 10. To prove that it's always even, we just need to factorize out a 2 to show that it is always even. And we're done. Brilliant. Now, differentiation is basically finding gradients of stuff. So the notation is f of x will goes to f dash x, showing this is differentiated. Now, you may also see d of dx, which means you're differentiating something in terms of x. For example, here I'm differentiating x squared in terms of x. Now, for dy by dx is when you have something like y equals x squared. When you have this, you will use dy by dx to show that you're differentiating y in terms of x. So in this case, I get 2x. And I'm going to show you how you can find a 2x from this definition. Next, a very important idea, when you differentiate, you are finding the gradient. So we always know that gradient is change of y over change of x, but with differentiation, you can find the gradient of curves. So for power rule, when we have y equals x to the power of n, for example, x squared, what we do is that we pull down the power and reduce the power by 1. So I'm going to get nx to the power of n minus 1. So for example, for x squared, when I differentiate it, I pull down the power to get 2x. Now reduce the power by 1 to get 2x to the 1, which is just 2x. And that is why I know the derivative of x squared is 2x. Now for something with a coefficient next to the x, it's the exact same procedure, but you need to multiply it by the coefficient as well. So for example, 3x squared, if I differentiate that, I will get 6x because I'm pulling down the power, multiplying by the coefficient, reducing the power by 1. So very quickly, if we differentiate this, we can say that dy by dx, because I'm differentiating y in terms of x, is equal to 15x squared, because I'm pulling down the power, reducing the power by 1, plus 8x plus 5. And the 6 actually disappears because we have 6x to 0. So when we pull down the 0, everything disappears. Brilliant. So to finding gradients of tangents, we need to know what tangents mean. For tangents, they have the same gradient. So let's have a look. We have this cubic. So if I put dy by dx to find the gradient, I get 27x squared. Nope, I get 9x squared because I'm doing 3 times 3 plus 8x plus 5. Now at x equals 1, the gradient is equal to 9 times 1 squared plus 8 times 1 plus 5, which is equal to 9 plus 8 is 17, so I get 22. So the gradient is 22, which means the tangent must have y equals 22x plus c for the tangent. And finally, I can find c by putting in my coordinate 118. So I can say when x equals 1, y equals 18. Therefore, c equals minus 4. So I can say that the equation for the tangent is y equals 22x minus 4. Brilliant. So find the equation of the normal of the curve. So for normal, the gradients are perpendicular. So the gradients multiply to minus 1 because of perpendicular gradients from GCSE Higher Maths. So again, let's find dy by dx. This is equal to 9x squared plus 8x plus 5. And then at x equals 1, we get 9 plus 8 plus 5, which is 22 as our gradient. Therefore, the gradient of our normal will multiply with 22 to get minus 1. Therefore, the perpendicular gradient must be minus 1 over 22. So we get minus 1 over 22x plus c. Put in 1 and 18 into our coordinates. We get this, which means c will be 18 plus 1 over 22. I am not really bothered on what that is. And I put it back in and I get my full equation. Next. Okay, to find turning points, there are 2 ways to do this. We could either complete the square or we could differentiate. So I'm going to show you both methods. So to complete the square for this, all I need to do is half the b term. So b is 6, so I'm going to half it and say it's 3, and then square it. And then 3 squared gives me 9. So to cancel that out, I want a minus 9, and then I still have a plus 8 left over. So this will give me x plus 3 squared minus 1. And the coordinate of the turning point will be inversing this. So plus 3 will become minus 3, and then keeping this the same, minus 1. Or you could also do differentiation. So for this quadratic, dy by dx will be equal to 2x plus 6, and at the turning point, the gradient is equal to 0. So I set that equal to 0. I get x equals minus 3, and I put it back into the original equation. So I get minus 3 squared, and then plus 6 times minus 3, and then plus 8. So I get this is 9, this is minus 18, this is plus 8. So I get minus 1 as my y coordinate. which gives me exactly the same turning point. Brilliant. So for second derivatives, we are simply differentiating it twice. So for example, here, differentiate it once, I get this. And then differentiate it twice, do the exact same thing, I get 18x plus 4. Easy peasy. For the maxima and minima, if the second derivative is greater than 0, then it is a minimum point. But if it is less than 0, then it's a maximum point. So for example, this point will be a maximum and this will be a minimum because of how the local maximum and minimum works. Okay, finally, this is basically combining all the skills that you've learned, but in a very complicated way. So we want to sketch this cubic. And we know that x plus 4 is a factor. So I think what we need to do is to factorize this thing first. So we have x cubed plus 4x squared minus 3x minus 12 equals x plus 4 times some sort of quadratic. So to get to x cubed, I must have x squared. To get to minus 12, I must have minus 3. And if we compare the x term, we get minus 3x here, which is perfect because I have minus 3x there. So I actually don't have a b term. So this will be my fully factorized version. So if I set this equal to 0, I can solve. So I get x equals minus 4, or x equals plus or minus the square root of 3. And then these will be my roots, which is where my curve will cross the x-axis. And then for my y-intercept, it is when x equals to 0. So which means I just need to plug in 0 for all my x's. 0 squared minus 3, 0 minus 12. That's equal to minus 12. So that will be my y-intercept. So if I draw my graph, it's going to go through minus 4, minus root 3. It's going to go through positive root 3. And it's going to go through minus 12. But then I need to find my turning points. So to find turning points, I just need to differentiate that. So I can say dy by dx. So the cubic is up here. I can just pull the power down and then reduce the power by 1 to get this. Set that equal to 0, and I need to solve for x. So here, I'm just going to use a quadratic formula. So I get negative 8 plus or minus the square root of 64 minus 4ac, but in this case, because I have minus, it's going to be a plus. So I get 48, I think? No, 36. All over 2a, which is 6. So I get negative 8 plus or minus 10 over 6, which gives me either a third or I get negative 18 over 6 minus 3. So minus 3 will be somewhere here. So I'm going to be careful with my minus 3. And I'm going to have a third, which is going to be approximately here. So if I draw the positive cubic, it's going to look something like this. No, it's going to look something like this, because the turning point will be at minus 3. Turning point will be at a third and minus 3. And then it's going to pass through all the things that we drew. Brilliant. Matrices. So when we have ABCD as a 2x2 matrix, we are actually saying that we have 2 points of AB, something like that, AB, and then something CD. So I'm going to show you what this means. The identity matrix I is defined to be 1, 0, 0, 1. We pronounce it downwards. So we have 1, 0 here, and we have 0, 1 here. And that is the identity matrix. And this is very useful when you're doing matrix transformation. For example, if I have K0, 0K, something like, let's say 3, 0, 0, 3, if I just draw it out, I will see 3, 0 being here, 0, 3 being here, and then I will have my identity matrix 1, 0, 0, 1 here. So I can see that actually my shape is being enlarged by 3 times the length, 9 times the area. So I will say this is enlargement by a scale factor of 3 is what I'm going to say. So we can also do it for rotation. So 0 minus 1 is at here. 0 minus 1. 1, 0 is at here. But my normal identity matrix is at 1, 0, 0, 1. So because we have 1, 0, 0, 1, my 1, 0 has gone to 0 minus 1, and my 0, 1 has gone to 1, 0, which means it's a rotation clockwise about the origin, about 0, 0 for 90 degrees, right? So I'm going to skip a few rotation and do a reflection one for you guys. So if I have 1, 0 here, and then 0 minus 1 here, notice that my my identity matrix here and 1, 0, 0, 1, this point went here and this point stayed the same. So this is a reflection by the x-axis. And you can do all of these using the same method. Okay, and then we have matrix multiplications. When we're multiplying two 2x2 matrices together, we're doing the first row times the first column. So we have AE plus CF. And then for my top right, we have the first row times the second column. So I have AG plus CH. And then we have BE plus DF. And then we have BG plus DH. So to put this into an example, when we do this, we have 3 times 2 plus 4 times 1 by doing this. And then we have 3 times 0 plus 4 times minus 1 by doing that. And then we have 2 times 2 plus 1 times 1. And then finally, we have 2 times 0 plus 1 times minus 1. So here I will get 6 plus 4, which is 10, 0 minus 4, which is minus 4, and then I get 4 plus 1, which is 5, and then I get 0 minus 1, which is minus 1, and that is my matrix multiplication. Brilliant. And then we have solving trig equations. So there are several important identities that we need to know, which is tangent of x equals sine x divided by cos x. And then something called the Pythagorean identity, which is sine squared x plus cos squared x gives you 1. So we can use these facts to solve our equations. And in further maths, we also need to consider multiple solutions to an equation. For example, we have cos theta equals root 3 over 2. So we know that with our exact values, theta will be equal to 30 degrees. But we need to draw a graph to make sure that we're not missing any solutions. So if we have the cosine graph, it's going to look something like that. At 30 degrees here is root 3 over 2. But because by symmetry, I must also have another solution all the way here, because that height will also be root 3 over 2. Which means I need to find what angle this is. And the answer is, if we have 90 degrees here, because cos 90 is 0, and then we have 180 degree separation here to get to 270, the distance between 90 and 30 is 60. Therefore, the distance between this and that will also be 60. So this point will be 330 degrees. Therefore, our second solution is 330 degrees. And there are infinite many solutions, but because we are bounded by this range, we can just say these two are my solutions. Brilliant. Then we are solving more equations. Solve 3 tan squared theta minus 1 equals 0. Brilliant. So first what I'm going to do is I'm going to add 1 on both sides to get this. I'm going to divide by 3 to get this. And then square root both sides to get plus or minus, do not forget that, 1 over root 3. So to solve for this, well, first of all, I know that tan theta, well, I know tan of 30 equals 1 over root 3. So theta equals 30 degrees must be a solution. But if we draw the graph, This is 0 to 90 with the asymptote, and then 90 to 180, and which is what the range we need. At 30 degrees, this is 1 over root 3, and that's fine. But for minus 1 over root 3, it's going to be somewhere here. And because this is 30 degrees, this is 90, the distance is 60 here. Therefore, there must be a distance of 60 here as well. So my other solution will be 150 degrees, because that's 90 plus 60. Brilliant. Finally, some trig identities show that this equals that. Whenever you see the word show that, you are going from the left-hand side to the right-hand side of the equation. So you're not manipulating both sides at the same time. You're only doing one side and you want to bring it to the other side. So we have 2 cos squared theta. We want to bring it to 2 minus 2 sine squared theta. So remember that sine squared plus cos squared equals 1, which means I can rearrange this to say that cos squared theta equals 1 minus sine squared theta. So I can replace that with 1 minus sine squared theta, and I can expand the brackets to get 2 minus 2 sine squared theta, which is what the question asks us to do, which is brilliant. Finally, this is at the very, very extreme end of the curriculum, because it's technically not in the spec, but it showed up on the specimen paper for the math, so I kind of need to include this. So the idea is that, first of all, we need to replace cos squared with 1 minus sine squared. So we get that. And then I'm also going to take away 3 so that I can set it equal to 0. So here we have 2 minus 2 sine squared theta plus 3 sine theta minus 3 equals 0. So 2 minus 3 gives me minus 1. And I get plus 3 sine theta and then minus 2 sine squared theta. And then what I'm going to do is I'm going to add everything to the other side, so I have a positive coefficient for my sine squared theta. So I get this when I add everything to the other side. And then finally, we need to spot that this is actually a secret quadratic. So if I say let u equals sine theta, then I can say this is 2u squared, because sine squared is u squared in this case, minus 3u plus 1 equals 0. And now I'm going to hope that this factorizes into 2u and then u. So I think if I do minus 1, it works. That equals to 0. So I get u equals a half, or u equals 1. But what is u? U is also equal to sine theta. So sine theta equals a half, or sine theta equals 1. And we're solving in between 0 and 180 degrees. So we need to consider all the possible solutions. So if we draw the graph of sine, we see that theta is 30, obviously, because of exact values. But we also need to consider the values that is beyond this, which is the symmetrical value for a half, which is 120 degrees. And then we also have theta equals 1, which is at 90 degrees because of our exact values. And because that's 180, the next time that sine theta is 1 is going to be beyond our range. So our final answer is theta equals 30 degrees, 90 degrees, 120 degrees. And that is the solution. And also that is everything in further maths covered. Thanks for watching. See you later.